Sorry, have you seen my screen?
Yeah, it's good. It's good, Binh.
Yeah. Thank you very much, Professor Krishna, for very nice introduction. And I have to say thank you a lot for giving me a lot of support during my time at UIC. And again, you have given me a chance today to share my research works to the researchers related to machine learning based natural hazard assessment at the regional scale. And I also thank to the people, the researchers, the professor today who have spent their time to attend this seminar. And hopefully that we can have some kind of like sharing the ideas and information, and hope that you enjoy with presentation. So let's talk a bit about my personal information. Professor Krishna have also introduced me, but I want again to share with you some more information. My full name is Pham Binh. Now, actually, on my research paper, I often put Binh Thai Pham in the international way, but in a Vietnamese way, Pham is the last name, and Thai Binh is the first name. So the people here in Vietnam they call me Binh, but when I go to another country they call me Pham. So I'm from Vietnam, and I'm working as an associate professor and as a head of the geotechnical and artificial intelligence research group, and I'm also working as the editor-in-chief of the Journal of Science and Transport Technology. So if you have any research paper would like to publish in my journal, so please don't hesitate to submit it. Um, and currently, I came to Professor Krishna University for the Fulbright research scholar, and I really had a good time over there with the support from the faculties and from Professor Krishna as well. So I graduated bachelor and master in Vietnam, but in 2018 I received a PhD degree in civil engineering at ZTU in Gujarat, India. So I spent four years in India. So somehow that I consider Indian as my second home country. And thank you a lot, because today I have seen a lot of attendance from India. And let's talk about a bit. Let's talk a bit about Vietnam. So uh, most people they know Vietnam as a small country located in the Southeast Asia. So we share the border with China, with Cambodia and Laos, and we have very long beaches. So if you come to Vietnam, so don't forget to visit the beaches in Vietnam, because they are very beautiful. I can suggest. And most people they know about Vietnam through the wars between Vietnam and in the past with America, with China, with Japan, with France. But nowadays we are very good partners. Um, Even with America, we have the highest level of relationship. So partners of the partners, and we have a lot of nice places for sightseeing. You can go to Halong Bay. You can see the scenes behind the King Kong movie. So they shoot it at the Halong Bay in Da Nang, in Da Nang, and in some very nice places in the mountain and mountainous areas. So please consider to come to Vietnam, and let me know if you come, so I can host you. Another information I would like to share with you about my university, the University of Transport Technology, located in Hanoi, the capital of Vietnam, and we belongs to the Ministry of Construction. We have a 80 anniversary so far, And we can say my university is one of the oldest university in Vietnam after we get the independent. And we train the different disciplines in civil engineering, about mechanical engineering, about economic, about transport operation, about IT, electronics, telecommunication. And we have different programs about doctorate, about undergraduate, about master. And in 2025, we have about 25,000 students. And we have different partners all over the world. And I'm also the person who is in charge of international collaboration at the university. And why I'm sharing this information to you, that because I want um, to host you, in Vietnam or in my university in the near future. If you have chance to come to Vietnam, please come to my university and we can have talk and we can find some chance to have jointly collaboration in the near future. Okay, let's talk about my research works. So we can find my research research profiles on Google Scholar. You can type my name. You can find my research paper that I have published. And related topic today, I'm talking about machine learning based natural hazard assessment, a regional scale. I focus on a few main contents. The first one is I will talk about the overview of natural hazard risk assessment and tools used. Secondly, I will talk about the natural hazard spatial prediction that we all know is related to susceptibility assessment. The third part, I'm talking about the natural hazard temporal prediction that is related to the hazard assessment. And the fourth part, I will talk about the highest level of natural hazard assessment is about risk assessment. And finally, we will come to some conclusion and discussion. We all know about natural hazards that are very serious and affecting the human life a lot. They cause the human loss, they damage a lot of properties, infrastructures, damage of the environment. We can say that their impacts are very serious to the human life. But the problem is this, we all know about this problem. This is not a new problem, but why is still happening? Although a lot of researchers, we are working on this topic, but still natural hazards are occurring. And interestingly that, I mean like seriously that natural hazard seems occurring more and more and in more serious way. We can say it's because of the, climate change, about the urbanization or something like that. There are a lot of reasons why natural hazards still occurring, although we have a lot of research on that. So why doing the research about natural hazards? Uh, I can say that we have two approaches. The first approach, we often consider to study about uh, specific site study or regional study. Other specific site study, we consider one location, one specific site. For example, about landslides, we consider one slope, and we will evaluate the behavior of the slope, and we can evaluate the stability of that slope. Consider different factors using different methods. But in this presentation, I will not talk about that approach. I will talk more about natural hazard assessment at regional scale. It means that we will consider one area and we will try to evaluate and try to show which area is more risky to the natural hazards. So what is the meaning of this study? So if we know which area is more risky for the natural hazards, so the land use plannings or decision makers, they can provide some kind of like measures to prevent it, to minimize the impacts of natural hazards to the human life. And they can, make a better land use planning to prevent the natural hazards in such way. And we have different approaches, different method to assess the natural hazards at the regional scale. So I will talk about that later. So first, before I talk about the methods, we have to classify the definition of natural hazard assessment. This is confusing between the researchers. So when you read the research papers related to this topic, you will see that some research, they are confusing about the terms like susceptibility, like hazard, about risk assessment. Some researchers, they are doing the spatial prediction that is related to susceptibility. But what they write on the paper, they are writing about risk assessment. I mean, that is confusing. That's confusing. But here I would like to classify it. We have some terms. First, about susceptibility, that we are talking about the spatial assessment, that they will show which location is more susceptibility to the natural hazards. Then the higher level of assessment is about the hazard. It's about the hazard. The hazard, we will consider both the spatial and the temporal prediction or assessments. It means that we have to consider the time factor for the assessment, and we combine spatial and temporal assessment, and then we will have a hazard assessment. The highest level of natural hazard assessment is about the risk assessment. It means that we have to consider the probability of occurrence, including the temporal and spatial predictions, and the degree of loss. So in some framework, we consider the risk, including the hazard, also about vulnerability, also about exposure, or also about the consequences. So later on, when I'm talking about the specific study, so I will talk more about that. But before we go further, I would like you to classify the terms so that we can use correctly in our study. About methods used to assess the natural hazards at the regional scales, we can divide it into several methods. The first kind of methods is qualitative methods that we are based on the opinions of the experts. And then we can classify it into the high, moderate, and low. So these kind of methods are known as the subjective. So if the experts are good, so they can give the good judgment. And if the experts are not good, so they will give the bad judgment. So it's we can say it is subjective. The second kind of methods is a semi-quantitative methods that we are based on ranking and weights assignment by a given criteria. And then we can classify the risk index in the some ranges, and we can assign it with high, moderate, and low. This is more objective than the qualitative methods, but it's still not considered as the objective methods. And finally, the third kind of methods is quantitative methods that we are based on the probabilities and the percentage of losses losses expected, and we can based on some statistical methods or some kind of algorithms to generate the risk values based on the data that we collected from the past. And then we can classify it and we can evaluate the areas. So among those methods, nowadays we consider the quantitative methods are more objective, and we can say that it's more of favorable for researcher to do the natural hazard assessment. And today we are talking about the machine learning based methods. So it is in the quantitative methods. And we have tried to compare different methods in the same areas, and the results we have received prove that the machine learning based methods are more, we can say, are more accurate than the traditional methods. So you can say that few years ago, the people, they are trying to compare this type of methods, but nowadays the people, they are not comparing such kind of like studies. So it means that the machine learning based methods are proof. I mean, like, are proof that the advanced methods, and we can say that it's accurate methods for natural hazard assessment. um, for regional scale, after like assessment, we have to before using machine learning, so we have to use some tools to do the spatial analysis, or we have to generate the data, spatial data. So we have used a GIS application. Uh, Specifically, we have used ArcMap. We can say that that tool is very powerful compared with the map info before. This is more visualized and it's more. I mean, that is better tool in generation of data, in the spatial analysis, and in the mapping. I mean, in the showing the results from the models. So I think a lot of people, they are working on GIS nowadays, and the application of GIS is not only in natural hazard assessment, but also in different I mean studies. So let's talk about machine learning. So I think nowadays machine learning is a well-known term, and it's well-known, I mean, like techniques. I mean, in the scientific communities. Um, I share with you some story that in 2018, because I work on machine learning and AI during my PhD, because my topic is also related to this. But in 2018, when I graduated and when I came back to Vietnam, I don't know about other country, but in Vietnam, at that time, the term about the artificial intelligence, about the machine learning is still new, and the people, they are not, I mean, like, noticing it. And even like when I share my research, the people, they are somehow, they are not believe it. They don't believe that what I have done with the machine learning, with the artificial intelligence. I have some different difficulties at that time about sharing the research works. But nowadays, machine learning or artificial intelligence have been approved, and I think that most of people accepted that is very powerful tools, and that can solve a lot of problem in real world, including the natural hazard assessment. That was my story, but let's talk in detail. What's the machine learning? So machine learning is one of the, I mean, the branch of artificial intelligence. because artificial intelligence is a broadly term, not only about machine learning, they are also including about deep learning, about generative, AI or something like that. But machine learning is, I mean, we can say that it's a part of artificial intelligence. Um, it's the way we teach the machine to study, to learn the data through the algorithm, and then they can discover the relationship between the input and output, and then they can give the prediction. That is machine learning. And how the machine can learn, uh, here on the slide we have different way the machine can learn. They can learn through unsupervised learning, about supervised learning, and about reinforcement learning. I think this I will not talk in detail, but in natural hazard assessment we will consider the supervised learning models or algorithms, especially to assess the natural hazard. We have used classification models, and the natural hazard risk assessment is kind of the binary classification problems. It means that we have two output classes. We can say that one class is hazard, and one class is non-hazard. So we will try to use the machine learning to classify it. They will classify which area is hazard and which area is non-hazard based on a set of the factors that affecting to the natural hazard. So that's why we consider natural hazard assessment as a binary classification problems. And nowadays, with the development of the computer, development of the algorithm, we have a lot of machine learning models, from the single models, from the hybrid models, from ensemble models. We have a deep learning models, and we have optimized models. I mean, there are a lot of models and different type models that you can easily find it on internet. And some models are available as open source. You can download it, and then you can study it, and you can learn, and you can apply for your problems. And to process the modeling, you can use different tools. Like we can use Python, you um, you can use Weka, you can use MATLAB, you can, yeah, different like tools you can use. For beginners, you can search, you can try to use some kind of like Weka software for the beginners. And if someone know a bit about the programming, so you can try to use MATLAB. But I suggest you to try with the Python, because of Python is very powerful, and they have a lot of libraries, so you can find a lot of algorithms there. Um, uh, Luckily nowadays, you can use ChatGPT, right, to help you to generate the codes. Even like you, before we don't have it. Now I and my research group, we have to code, each line of the algorithm. But nowadays, with the help of ChatGPT, it's easily to generate the codes, and it's easy to solve the problem if you face during the modeling. So if you can take the advantage of ChatGPT or generative AI, so it is helpful. It help a lot. Okay, so what's the advantage and disadvantage of machine learning compared with traditional methods? That I think the people can find it on internet easily. We can say that the most advantage of the machine learning it's a subjective. I mean, it's objective, sorry. So we can provide them the data, the historic data, and then they can learn, and then they can discover the knowledge, and then they can give the prediction, or they can give some kind of knowledge for the decision maker. Um, Secondly, that the machine learning can handle with the big data. So big data here is not only about the number, it's about the complexity of the data as well. It means like with the problem with a thousand, and even you know that the ChatGPT, they have billion factors, input factors. So the machine learning or the deep learning, they can solve it. Why the traditional methods cannot solve it? Like in our case, like we have like 20 factors, we have a 30 factor, even like more than that. The machine learning can solve it. But the problem with machine learning, or the disadvantage of machine learning, is about it is very sensitive with the errors coming from the quality of the data. Um, yes, coming from the quality of the data, and also the way you design the problems. If you don't design the problem in a proper way or in the correct way, the machine will give you the wrong results. Or we can say that they will give you like the non-reliable results. Even the accuracy of the model is very high, but the reliability of the model is not good. Because the algorithm, they just can learn from the data you provided. And if the data is not representative or is not good enough, so the model will give you the wrong results. Even the accuracy is very high. And other thing is the machine learning models is not easy to be interpreted. I mean, like they are processing in the black box, right? Most of the model, they are processing in the black box, so it's not easy to understand it. Okay, and it for deep learning, for some kind of like complex algorithm, they will require time and resources. Yeah. One of the advantages of machine learning based approaches is that we can evaluate the models quantitatively based on some kind of like statistical uh, metrics obtained from the confusion metric. I think that if you are working on statistic, you will know about this, right? Some kind of like accuracy, about sensitivity, about the errors, about specificity. Those index we can calculate it. We can be calculated from the confusion metric. And we can use this one to evaluate quantitatively the quality of the models. Um, Another method that is well known is about ROC, right? ROC. So we can evaluate the model, the quality of the performance of the models based on the area under the curve, area under the ROC curve. And if the value of the ROC is close to 1, it means the model is good. But if the ROC is lower and is close to 0.5, so the model is not good. And that's the way how to evaluate the performance of the machine learning models. Okay, that is general information about natural hazard assessment. And now we will come to the specific study that I would like to share with you. I will go uh, from the spatial prediction up to the higher level of the assessment related to the hazard assessment, and then we will come to the risk assessment. First, I will talk about the spatial prediction of the natural hazard, and I will give the example of landslides. For another natural hazards, you can apply the same approaches. And when we are talking about spatial prediction, so it means it's related to susceptibility assessment. And here is one of the paper that we have published related to using some kind of deep learning neural network for the prediction of landslide susceptibility in Vietnam. And This is a study area. This is Vietnam, and this is an area that we have taken as a study area. And for generation of the data used in the modeling, we have two type data. The first one is about landslide inventory. This is very important. This is very important data. So the inventory, we can collect it from the field study, from the interpretation of the satellite image, like the Google image. In India, at that time when I was doing my PhD, I interpret Google Earth, and it's very easy to get the data. But in another area, like in Vietnam, when the trees or the land cover is very dense, so we cannot easily, cannot recognize it by eyes. So in addition, we can collect it from the historical reports as well, and then we try to combine it. But remember that we have to collect the inventory in, enough. What's enough? It means that we have to collect as much as we can, as much as we can, and we have to collect, uh, representative inventory. Otherwise, the model will learn wrongly. The model will learn wrongly. Second, second kind of data we have to determine is about the factors affecting to landslide in this area. So each area, the factors affecting to landslide will be different. Of course, we will have common factors that affecting to landslide in any area, but in each area they will have a specific, factor um, affect mostly or strongly to the landslide that we have to determine. And for example, in this area, we have selected 10 factors. At that time, actually, we analyze, and we know that there are more factors affecting to landslide in this area. But unfortunately, at that time, we don't have enough data. That's a problem. That's a problem. So then we decided that we have used that only the factor or the data that we have, and to see how the models performs. And this kind of a spatial analysis, we can do it using the ArcMap or GIS. We will know in which class the inventory is more. It means the landslide occur in the past more. So from here we can see, for example, like the distance to the road here, we see that most of landslide in this area occur nearby the road, right? Between the distance from 0 to 100 meters. So from here we will have the big picture of the landslide in this area. And based on of this one, we can generate the data sets. The data sets used in the modeling, we can construct it in this structure. So we have set up the factor affecting the landslide, and then we have the output. The output here is a landslide location. I code it as 1, and the non-landslide location I code it as 0. So the model will not understand what data is landslide and what data is non-landslide. So we have to put the coding for this one. And based on the spatial prediction, spatial analysis, so we can, convert the data into the range from 0 to 1 to make the data in the balanced way. So use its data, we divide the data into the training and the testing. This is a normal way for, do the modeling, right? So the training we use to train to build the models, and while the testing we have used to evaluate the predictive capability of the models. And in this area, we have tried to apply neural networks and deep learning models and another model as well. And the results we have seen from the ROC curve, we see that deep learning is the best compared to another models. Another, you can say that single models, and deep learning is better. But we can say that deep learning always better than normal machine learning models. We cannot say that. It's up to the data and up to the areas. And in our study, we have tried to apply deep learning in different kind of data sets in different areas. And we can say that somehow, if the data is small, the deep learning and machine learning have no difference in the performance. So that's normal, because deep learning normally the model will work in the big data. So if in the case you have big data, I would suggest you to use deep learning. But for the normal data, for small data or small problem, I would suggest you to use machine learning. So it will not take time, and it will not consume the resources. And another resource, we compare between the models, and we see that some models are, have significant in difference, and some models are not. And finally, we will have this map. We will see that we have, in this area, we classify into high, moderate, and low, and in different colors. But you will see the problem of this study. You see most of the red area, right? The high area is, is something is strange, right? Something is strange. It's along the road. You see here is the road. Here is the road. Why? Is it because most of the data inventory we have collected is along the road. That's why the model will understand it, and then they will give the results. It's like most of the area susceptibility area is along the road. So we all know about that. That's the problem with the data. I think so. That's because we don't collect enough data about the inventory, about the factor that we have used. So that's why the results you will see. So here I show you another study. We have applied different models in another province in Vietnam, and we have tried to compare the map that we have received from the models with the real data. I mean, after we generate this map, and some landslide have occurred in this area, and then we overlap it, and we have seen that this is a very big landslide and causing a lot of damages. And this landslide was located in the very high susceptibility area. So it means that the reliability of the map generated from the machine learning model is good. We can say that. And the detail of the final map is up to the detail of the data that you provide to the models. Okay, that's about the spatial prediction. Now we will come to the temporal prediction, and that we will talk about the hazard assessment. The hazard assessment, it means that we have to consider both spatial and temporal prediction. For spatial prediction, that I have shown you before, right? But now we will talk about temporal prediction. How to evaluate the natural hazard in the context of temporal prediction. And here I will show you, and you can search this paper online. We have carried out the landslide hazard assessment using some kind of like hybrid models, combining with the probability analysis of the rainfall data at the area in Vietnam. And for temporal prediction, we have to determine the time factors. I mean, the factor that is, affected by time. And here we consider rainfall as the time factors. And the factor you can consider like the earthquake, like um, the land cover, they also change, but it takes time. But normally we consider rainfall data as the time factors. And when we consider rainfall as a time factor, so we have to collect the rainfall data. The problem is when we are doing the temporal prediction, it's about the data of the rainfall at the time landslide occur. It's very rarely. I mean, not all the way you can collect that data. And in this study as well, I faced a lot of difficulties to receive that data. Although we can collect it by interviewing the local people, or we can compare the satellite image before and after the event or something like that. But it's still this data is very unique, it's very rare. So that's why you can see that not a lot of people are working on the temporal prediction. So I think mostly it's because of the data is not easy to be collected. And here we collect the data from 2008 up to 2013 about the daily data, the monthly data, and annual data. And here we see after we have data, you see that, for example, in the date of August, 9 August 2008, we have two landslides, and at the time the landslide occur, we have this kind of like info data. What's the purpose of collecting and determining this data? Is that we have to determine the rainfall threshold. The, at that time, at that rainfall, the landslide will initially occur. So that's very important for the temporal assessment of natural hazard. And here, based on the data we have determined the rainfall threshold through the 15 accumulate rainfall data. And from here we can see that when the rainfall beyond the 100 millimeters, the rainfall will be occur. And we evaluate this rainfall threshold based on the real rainfall data as well. And you can see that at this point, when the rainfall beyond the rainfall threshold, the landslide have occurred in the past. So it means that these results have been evaluated. And based on that, we can calculate the temporal probability of landslide occurrence based on this equation. And from that, we can calculate the temporal probability in different return periods, in 1 year, in 3 years, and 5 years. And using these values, combined with the spatial prediction, here we have used some kind of like hybrid models. The same with the first part that I have shared with you. All right, we have spatial assessment, and we combine with the temporal probability of landslide, and then we will have the final hazard map here. For the hazard map for 1 year, 1 year return period, and the 3-year return periods, and the 5-year return periods. So that's meaning of hazard assessment. Okay, now I will talk about the natural hazard risk assessment. This we can say that is the highest level of natural hazard assessment at the regional scale. And you can find some papers, our papers related to this on internet. And we have used some kind of hybrid artificial intelligence models for the flood risk. In this study, we consider as a flood. The data is similar that we have to collect the inventory, we have determine the factor affecting to the flood as well. But for the flood, we have to, for the risk, we have to determine the conceptual frameworks. In literature, there are different frameworks for risk assessment. Some researchers, they are using flood risk equals to susceptibility multiplied with consequences. But some researchers, they are consider three parts: susceptibility, hazard, vulnerability, and exposure. They are combining together. So first you have to determine the framework, and then we can do the modeling. We can prepare the data and do the modeling, right? And in this area, we have used this conceptual framework of risk. And it means that flood risk, we consider susceptibility multiplied with consequences. And this is the flow map of this study. For the hazard map, we for susceptibility that we have similar approaches that we have I have shown you in previous slides. But for the flood consequences, we are consider different factors. Here we have considered human health, about financial impacts, or this kind of like data that we have collected. You can collect more data, you can consider more factors, and then you will see how different it is. But in this area, that's because I can say that in our study, because limited the funding as well, we have used only the data that we can collect. And but the important factors should be there. Important factors should be there. And you will see. And this is a validation of the models for the susceptibility assessment. And here we see that the performance of the models are good. You can see the accuracy is more than 90%. It means the models are good. And accuracy, the area under the ROC as well, you see that it's very high, right? It's very high. So it means the models are very accurate. And this results also, they are showing a very good performance. And this is a map of susceptibility, right? Similar with the landslide that we have, I have shown it before. And for the consequences, we have used the ways of indicator using SAP. Actually, this is the semi-quantitative models. It's not fully, I mean, like quantitative models, but we can consider it and to generate the consequences assessment. Actually, we can also use machine learning in this way, but we need more data. We need more data. But in this study, we do not have. So we have used this kind of like semi-quantitative model for generation of consequences maps. And you see the weight that from the models they are given here. And finally, we generate the maps of consequences, and we have consequences of human health, consequences of financial impact, and combine them, we will have a consequences value map. And finally, we combine the susceptibility and consequences, and we will have a final flood risk maps. You will see that some areas very, extremely high risk. The red color is extremely high risk, and other as well. And this information, I think, is very useful for the land use planners and decision makers. In another study also related to flood risk, you will see how different when we are using different framework of risk. In this area, we have used the same data that we have used in previous paper, but we have used different frameworks. You will see how different it is. These are the framework that we have used in this study. We have considered flood risk with hazard, with exposure and vulnerability. For the hazard, we consider flood accessibility, for depth, flood duration. For vulnerability, we consider poverty rate, road density, the number of deaths, or something like that. the framework, this framework is different with the previous one. The same, we will do the susceptibility, right? The same process. And here we have a use deep learning and another kind of models. And we will see that the accuracy of the models are very good. And for the another flood hazard, flood exposure, and flood vulnerability, we have used the MCDE analysis and to generate the weights and generate the final maps of flood hazard, flood exposure, and flood vulnerability. And here we have a flood susceptibility map from the models, machine learning models. We have flood hazard, exposure, and vulnerability map generated from MCDI. We see that this is a map. And finally, we combine it, and we will have the flood risk maps. You will see. You see. I will bike it. You will see. This is a map from the framework one, right, for flood risk. And this is another map from another framework. You see, it's very different, right? It's very different. So that's why you should be careful to use a framework and from user models, from the user data as well. So I will come to the conclusion. The first, I can say the machine learning is a promising tools for natural hazard risk assessment with high accuracy. High resolution and more detailed data should be used for better performance of natural hazard risk modeling assessment. And more advanced machine models should be developed and applied in other natural hazards prone areas of the world. And natural hazard risk assessment maps should be used for better land use planning and decision making. And one of the last thing I would like to share with you related to this topic is the models or the AIs or the machine learning, they are, we can say that they are the methodology or they are the tools used. But the performance of these models are based on the data that we provide for them and the way that we design the problems, the way that we design the problem. If we design the problem wrong, the model will give the wrong results. And if the data is not good, it means it's not representative and it's not, enough or it's not qualified. So the model will give you the wrong results. So two things you have to keep it in mind while you are applying or developing the machine learning model for this problem. The first thing about the problem design, you have to design the right problem. And then the secondly is about the data, how to use the data. That's very important. And okay, so I'm also working on another problem as well. I would like to share with you because maybe someone you are interested in, so we can, we can chat, we can talk, or we can share in detail after that about another geotechnical problems, about, predict classification of the soils as well using machine learning. This multi-variable classification models. For the natural hazard, we are considered as a binary, right? Binary classification. But in this problem, classification of the soil, we consider the multi-variable classification problems, models, sorry. And also we try to use some kind of like regression models to predict some kind of like the bearing capability of the pipes, the soil properties as well, and other similar problems. And finally, I want to close my presentation by one thing. What I realized up to now, it's not about the models. Now, the problem is not about the models because I think with the machine learning, development of machine learning and deep learning about generative AI, now models are not a problem. It means we can say that we have enough models to use. But now the problem, even in my country, we are facing as a researcher, that about the data. data, how we can collect reliable data, and how we can collect enough data. That's a big problem, and that we have to care about. Thank you very much for listening. I would like to stop my presentation here. I don't know, maybe it's a little bit more time. I'm sorry, Professor Chris.
That's perfect. Thank